Conditional logistic regression. Okay, the word logistic regression, you're the expert. The word logistic regression, you know already. You have analysis where the outcome is dichotomous. Okay, where the outcome is dichotomous. But if that one, usually for logistic regression, when you do the analysis, the starting point, the univariate analysis, you were doing chi-square. So chi-square, you proceed with logistic regression. Some of you, due to the advice of your supervisor, you end up doing a match case control study. I repeat, you do end up doing a match case control study. If you're doing a match case control study, you cannot use multiple logistic regression. If you're doing a match case control study, for the multivariate analysis, you have to do conditional logistic regression. So I would like to remind you all, number one, do not do match case control study. Okay, that's first one. I know EPID like to do this a lot. They like to do match case control study, then they do matching 5 to 1, 4 to 1. Okay. Okay. Why I do not want you all to do a match case control study? One, when you're doing analysis for univariate, you cannot use chi-square. The minute you use match case control study, you have to use a different type of analysis for univariate. Can anybody tell me what is the analysis for match case control study? Senyap, eh? McNemar. Yes, McNemar. Thank you very much. So you have to do McNemar. My problem is, most of the lecturers, as you all know, McNemar, you can only do for matching 1-to-1. But sometimes, I have lecturers who are asking the student to do matching 2-to-1, 3-to-1, 4-to-1. Okay, why? Because they want to increase the sample size. They want to make the numbers look big. So when they come to me for analysis, I ask them, if we're doing matching case control study, you cannot do chi-square. The minute you say you're doing matching, you have to use McNemar. And when you're doing McNemar, you cannot do a McNemar if the matching is not 1-to-1. Only for 1-to-1 matching that you can do McNemar. What I'm asking to you all right now, number one, do not do match case control study. Do unmatched. When you're doing unmatched, beautiful. Why? You can use multiple logistic regression. You can use normal chi-square analysis. The minute you use matching, you end up having to do McNemar and you end up having to do conditional logistic regression. Okay. Does it have an effect on your chances of being published? Okay. As I said before, ignorance is bliss. Or like the Malay translation of it, bodoh itu bahagia. Jadi sebenarnya 33% of all papers published on match case control studies are using the wrong analysis. So if they are published, means there are a lot of people who do not know statistics. But the number of those who are reviewing papers, nowadays they tend to add on one epidemiologist to review paper. So when that thing happen, okay, you have to be very careful, because there has been a lot of situation where the papers were written because they were doing chi-square and logistic regression instead of McNemar and conditional logistic regression. About 4 years back, one lecturer from pathology complained to me that her papers was being written by the reviewer because the reviewer said, you are using the wrong analysis, you're supposed to use McNemar. So she asked me for help. But the only thing she got was the chi-square table. I told her, if you want me to help, you have to get me the original data set. Problem? Student already left. When student already left, under the other departments, they do not keep the data set. So the data set is gone for good. So I hope you understand. The only reason you are learning conditional logistic regression today is because just in case any of you do match case control study. So what is conditional logistic regression? It is an extension of binary logistic regression. So conditional logistic regression is the extension for binary logistic regression where you have the outcome has only two levels, like case and control. Okay. Why case and control? Got cancer, don't have cancer, but are matched by something else. Example, you are matched by gender and age, or they are matched by race. Okay. So if it is unmatched, you just use chi-square and multiple logistic regression. So if it is matched, we use McNemar and conditional logistic regression. Okay. The best part is in SPSS, there is no conditional logistic regression. So how do you do it? So you end up having to do the data using the command multinomial logistic regression, or by using Cox regression. Multinomial logistic regression is when you are matching one-to-one. Cox regression, it is when you are matching one-to-one or one-to-many. The data set are arranged differently. Okay, I'm going to show you the first one using multinomial logistic regression. So if you look here, subhanallah, very difficult to understand. Why very difficult to understand? Okay. The top one is how you tend to enter data in your SPSS. So usually you have two groups. Example here, these are the cases, these are the controls. So you can see here, they have the same pair of data, x1, x1, x2, x2, x3, x3. If this data, you are keeping it for analysis using the multinomial command, you have to get the difference. You have to get the difference. So now what happened is, please focus on the continuous variable first. So we have the x1, x1. Okay. So you have to get the difference. So the cases minus the control. I repeat, the cases minus the controls. So 83.1 minus 86.1, you end up with a value of negative 3. 84.6 minus 87.3, you end up with a difference of minus 2.7. So that is for the continuous variable. So the cases minus the controls. The same thing applies for categorical data. For categorical data, the cases minus the controls. 1 minus 0, 1 minus 1, 1 minus 0, 0 minus 1, 1 minus 1. So end up with the difference, which is 1, 0, 1, minus 1, and 0. That is for dichotomous. Problem arises when you have polynomial data. When you have polynomial data, you have to separate the data. So your first step is to separate for Malay, okay, then you separate for Indians and so forth. Let me explain. Here in this data set, Malay is coded as 2. Malay is coded as 2. So now what happened is they come up with 3 variables from this one variable. Okay, so 0, 0, 1, 1, 1 for the Malay. For the Indian, 0, 1, 0, 0, 0. For the Chinese, so because the reference group is Chinese, they're going to compare against the Chinese. So they did not come up with the Chinese one. So they get for the Malay difference and the Indian difference. Okay, there is no Chinese difference. So that is why it is messy for multinomial. Okay, so please take note, for the difference, it is always case minus control. Okay, please download the dataset. This is the example that we got from Chan. Okay, please take note, they have the outcome 1. Okay, now is the messy part. The messy part is how to run the analysis. Okay, so remember we had the outcome coded for everything, for the difference. Okay, then all the different variables you have to put into the covariates. Uncheck include intercept in model. So you have to use the main classification effects. Okay, so the main effects model, as you can see, not valid. Goodness of fit is not valid. Classification table is not valid, but the rest are all valid. So you have the model fit information, likelihood ratio, and the R-square statistics. So right now, I'm going to demonstrate how it is done. Analyze, regression, multinomial logistic. Outcome is here. Alright. Next thing, is a reference category, first or last. Okay. So you have to see your code whether it's first or last. In our situation, there's no point. Why? Because there is no first or last. Everything is coded as 1. Okay, so when you click OK, they say dependent variable has only one valid value. A conditional logistic regression model that will be fitted. So they have unexpected singularities. Okay, why they have this issue? Because the sample size is quite small here. Okay, and they come up with all this table, the R squared and so on and so forth. Okay, so of course we're not getting the same one like what Chan got, but this is because we are only using a small subset of the data. Okay, let's look at Chan. So Chan, they say their results look like this. Okay, their result look like this. So what's the explanation? Okay, let's look at the data set. Okay, the p-value, everything not significant except for the x2, x3, and the diabetes mellitus. Okay, the beta is 1.065 for diabetes difference. So you can see here, case minus control. So if it is coded as 1, so if the value is 1 or larger, higher rate of diabetic among the death. So you can see the results. Data came from Sabah. So let's go and try the analysis. Okay, so let's look at the data set. So click analyze, regression, multinomial logistic. So the dependent outcome, again, this one is malaria. Then you have to get the difference. The difference we already calculated for you, all the differences. So paying the price of being sleepy. Doctor, why are you sleepy? Because when I wake up at 5 o'clock, I cannot go back to sleep. Okay, take all the difference. Take all the difference. Wow, so sleepy. Oh, I think there's a high chance of me falling asleep as I'm giving the lecture. Okay. For the exam that day, I gave this data set for the exam. Doctor, you are being cruel, doctor. Nobody can answer. So put on the covariates. Order main effect do not include intercept. Statistic, take out step summary. Otherwise everything is okay. Click continue. Click OK. Okay, so look at the results. So look, focus on the significant ones. So what significant? Job difference. Okay. Of course lah, you work in the jungle, you end up higher risk lah. How high? Pune beta 21 times higher. So if you work in the jungle, you are 21 times higher. Okay. What else is significant? Number of household members. Wow. Repellent. Use repellent or not? You use repellent, less risk. Movement difference. You go move the jungle, you are higher risk. So and so forth. Okay. So this is what they call multinomial logistic regression. Okay. Doctor, you're supposed to do McNemar. Yeah, I forgot. Sorry. Click analyze. Cross step. Okay, row is the control, column is the cases. Row is the control, column is the cases. Okay, job of cases masuk ke column. Job of control masuk dekat row. Okay. So problem you have to do like this, one by one. Cells, because this is McNemar. McNemar is not row percent, it's total percent. Okay, continue. Statistics, McNemar. Continue. Click OK. So you get the answer for this one. So this is the example. And as you can see, it is significant. How do you control for other variables? Then we do the conditional logistic regression. Okay, alright. But as I said just now, some of you are not using one-to-one, some of you are using one-to-many, or you have more than one control for every one cases. So you cannot use multinomial logistic regression. So you would like to do using the Cox regression. Cox regression, the beauty of using Cox regression, the data is only rearranged as a single column. What do you mean by single column? Okay, you can see here, these are the cases, these are the controls. So now the cases and controls are side by side. Doctor, even messier what, doctor? You have to type in one by one. No. What I do, I just cut and paste. So I cut the one on the right side here, I cut, then I paste at the bottom. Then I put in the number. After I put in the matching number, then I sort again. Okay, so it is in fact easier because you don't have to get the difference. You just have to shift the control to be underneath the cases. But you don't do it by one, you do it all together at the same time. Okay, you have to come out with the code for status and the code for time. Because Cox regression require to have status and time. So how to decide for the time? For the time, the control are coded as 2. The control are coded as 2. The cases are coded as 1. Next, we have to come up with the status. For the cases, they are all coded as 1. For all the controls, they are coded as 0. So you have to create 2 new variables. You have to code 2 new variables. One is status and the other one is time. Date status is 1, time is 1. Control, it is coded as 0 and 2. So we need a matching number to link the case and control, and that matching number is the variable pair. So date is the outcome status. Okay, they clear already. We explain variable time as my variable. So where does the pair comes in? The pair one comes under strata. The pair one comes under strata. So click on Analyze, Survival, Cost Regression. Remember time. Okay. Status. So status coding is 1. Okay. So that is then everything else is the variable of interest in the analysis. Okay. So we're going to put in like this. Okay, what are we going to put in? Race, education, job, pay, own TV. So here we're going to put in race, education, job, pay, TV. Okay. By right, it's supposed to select the significant one from the McNemar lah. But I did not do the McNemar. Own motor. Okay. Own motor, own car, rescore. Own car tak. Match number. Okay. Select everything. Reference first. Click continue. Now we click on OK. Okay, so there's the results. Conclusion. The variables that are significant are risk score only. Okay, and so that is how we do the analysis. It is not the same. Risk score only.